Okay, folks, welcome back for another video here for Chapter 4 on rational functions. Today we're going to be talking about graphs of rational functions. So basically today, because we're talking about graphs, we're going to make your graphing calculators obsolete. After you're done with this video, you would be able to graph a function like that without your calculator. So let's get started. And first thing I want to talk about is this continuous versus continuous on its domain. This question doesn't directly relate necessarily to what we're talking about here, but it's an important idea, I think, in mathematics, so it seemed like an appropriate time to include it. I'm going to let you go ahead and read the question there. Go ahead and pause the video, read it, think about it for a second, and then I'm going to tell you what I think the right answer is. No, seriously, pause the video and read it and try to figure out how to answer this question on your own. Okay, here we go with the answer. Okay, so an important idea here. Again, this function's not continuous on the real numbers. Take a look at the denominator. You got a value there that could be 0. And if that value is 0, then the function is undefined. But this function is continuous on its domain of from negative infinity to infinity, just excluding 0. Remember this notation right here just means x cannot equal 0. So just again, important idea that I wanted to mention in mathematics, and we are going to be graphing rational functions today. They are continuous on their domain. This begs the question, and I know somebody out there wants to know, well, how could you draw a function that is not continuous on its domain? And I'll wait for somebody to ask me that in class, and we'll see if we can come up with an answer. All right, let's move on. So big idea here will be for graphing rational functions is we need to be able to construct a sign chart for rational functions. And you can go ahead and read through the steps here, but notice that I have step 0 as draw a number line. So we're always going to start there anytime we're drawing a sign chart. So I've got this function right here, f of x equals 3x over the quantity x squared minus 4. And I'm going to start by just drawing a number line. Okay, so there's my number line. And I'm going to, the way I do sign charts is I put the function values on top and the input values on bottom. Okay, so let's go to step 2. We're done drawing our number line. Step 2 says identify all excluded values from the domain and mark them with a unique symbol. Okay, your textbook uses this symbol right here. It is a question mark and an exclamation point at the same time. So it really looks like this. You know I like to draw my exclamation marks like that. So it's called an interrobang. I'll let you take a look at your textbook if you want more information about the interrobang. But interrobangs are supposed to draw our attention to a unique number that we should look at with a sense of awe and wonderment. Okay, so that's great. So now that that's over, let's go ahead and see if we can't finish off the sign chart for this function. I'm going to extend my number line out here a little bit. There we go. Okay. So any excluded values from the domain? Well, I'm sure there's some values here that are excluded. If I'm looking at x squared minus 4, I think I could rewrite that. I'd like to factor that thing out. So x squared minus 4, difference between two squares, factors into x minus 2 and x plus 2. And I still have 3x in my numerator. So what values are excluded from my domain? That's going to be negative 2. And that's going to be positive 2. And again, I'm marking those with a symbol to identify that, hey, these values are not in the domain of the function. From previous sign charts we've done in class, you know that I would put a 0 there, but this is the values of positive and negative 2 are not zeros. Okay, so again, I just want to make special note of that. f of x is undefined at x equals plus or minus 2. Okay. Step 2 of the procedure here says find the zeros and mark them with a 0. Well, it looks up from here like my numerator. This is something you need to know. A rational function can only equal 0 if its numerator equals 0. So that means f of x will equal 0 at x equals 0. So I need to mark that point on my number line and identify it as a 0. Okay, so we're done with step 2. Now we go on to step 3. I need to choose a test point in each interval. So let's pick a test point here, like anything positive that's to the right of 2. Like let's pick the number 3. Let's try 3. My numerator, 3 times 3, that's a positive number. My denominator, 3 minus 2, that's positive. Let me mark these here, folks. 3 minus 2, that would be positive, and 3 plus 2, that would be positive. So if I have the product of a positive, my denominator is positive, and my numerator is positive. So any value out here will be positive. Okay. So now let's pick another test point and try it out. We'll pick a point between 0 and 2. Like 1 seems to be a logical point to pick there. 3 times 1 is positive. 1 minus 2 is negative. 1 plus 2 is positive. So if I take a negative times a positive, that's negative. A positive divided by a negative is negative. So my sign chart is going to be negative in that region. And remember, a sign chart really is just the graph of a function without a y-axis. So I'm telling you that y-coordinates here are positive, y-coordinates here are negative. All right, let's pick another test point. How about negative 1? 3 times negative 1 is negative. Negative 1 minus 2 is negative. Negative 1 plus 2 is positive. So these two negatives turn into a positive, so my result here is now positive. All right, continuing down the number line, let's pick a test point over here like negative 3. So 3 times negative 3, that's a negative value. Negative 3 minus 2 is negative. Negative 3 plus 2 is also negative. So now I have a positive in my denominator, a negative in my numerator. Overall result is a negative. Okay, so we got a sign chart drawn for this rational function. That's great. What do we do with it? Well, for now we just look at it and say, hey, I know a little bit more about the function than the person next to me. But we're going to use that information to graph the rational function, 3x divided by the quantity x squared minus 4. And remember, this is the function we just looked at. And we know that this factors into x minus 2 and x plus 2 in the denominator. And my numerator is 3x. All right, so the gray box on the left here contains a 6-step procedure for graphing rational functions. I'm going to zoom out a little bit so we can see the entire page. Bear with me. Okay, so there I can see the whole thing now. So I'm going to graph this function in this graph paper region right here. I'm going to need some x and y axes. So let me insert those. And shift that a little bit so we are lined up on the graph paper. There we go. Okay, so I got my x and y axes. That's great. I would like to shorten that up a little bit. Okay, there we go. All right, so the first step of this procedure is to find the domain. Well, we've already identified values that are not in the domain from our sign chart. That's plus or minus 2. So the domain is x cannot equal plus or minus 2. Reduce to lowest terms. Well, there's no factors here in the numerator and denominator that cancel, so this step is not applicable to this function. Find the x and y intercepts. Okay, so this is this one is you need to understand how to find the x and y intercepts of a function. Well, we know the zeros, the x-intercepts occur at f of x equals 0. And that only occurs, we have a 0 at x equals 0. And that's the only one. Okay. So if we plug in, so we have a 0 at x equals 0. But that's also our y-intercept. If you plug in 0 to the function, you get an output of 0. So this one is kind of trivial. We have an x and y intercept that are the same. In fact, why don't I go ahead and mark that point on my graph right now. Okay. Find vertical asymptotes and holes. Analyze behavior on either side. Well, let's talk about the vertical asymptotes. If you recall from the previous lesson, anytime we have a 0 in the denominator that does not cancel with 1 in the numerator, that's the location of a vertical asymptote. So we're going to have vertical asymptotes at x equals 2 and x equals -2. So I'd actually like to include those on the graph right now. So I've got x equals -2 and x equals, whoa, that's not what I was hoping for. And then I got x equals +2, which are going to be vertical asymptotes. So let's go ahead and identify those. X equals -2, x equals +2. Okay, so those are the locations of our vertical asymptotes. The other thing we have to do is identify locations of holes, and there are none in this graph because we have no factors in the numerator that cancel out with the factor in the denominator. So I'm just going to make a note over here for holes. We have none. Okay. The next thing, step 5, analyze the end behavior or find the horizontal asymptote or slant asymptote if they exist. Well, let's take a look back up in our function. The degree of my denominator is larger than the degree of my numerator. If that is the case, then I have a horizontal asymptote at y equals 0. So I'm going to also identify that on the graph. We know that our function is going to approach the x-axis at its end, at x equals plus or minus infinity. So my horizontal asymptote is going to be the x-axis. I'm just going to note that as y equals 0 over here. Okay, step 6. Use a sign diagram to determine the shape of the function. Well, okay, so let's see what our sign diagram tells us. It tells us out here beyond x equals 2, so to the right of x equals 2, my function is positive. Okay, I have a positive function, but I also have this horizontal asymptote and this vertical asymptote. Remember, a graph cannot cross a vertical asymptote, and as x goes towards positive infinity, we have to approach the horizontal asymptote. So the only way that can happen is if our graph does something like this. Okay, so we're done. We've graphed the part from 2 to infinity. Now we have to graph between -2 and +2. Those are those two vertical asymptotes in the middle of the domain here. But we have to go through 0, 0. So we start between 0 and 2, my function has to be below the x-axis. Between 0 and -2, my function has to be above the x-axis. The only way that can happen and stay between the asymptotes is to do something like this. There you have it, folks. We're almost done. We have one more piece of the domain here to graph. We have to graph to the left of this vertical asymptote, x equals -2. My sign chart says the function has to be negative. I also have this horizontal asymptote I have to be aware of here. The function is negative, and stays between the asymptotes. Folks, give yourself a little pat on the back. You just graphed your first rational function without a graphing calculator. Folks, I was really bothered by the way I drew that middle piece of the function, so I tried to redraw it there. You deserve better than what I had up there before. This is a little better. I hope you can work with this. Okay, enough for that. Let's go on to page 2.